Hello everyone, welcome to HC Tutorials, and today we are looking at free body diagrams. So the reason why we draw free body diagrams, it's because it makes us see all the forces that are acting on an object and thus making it very simple for us to do calculations whenever we have to do calculations. Okay, so without wasting much time, let's get to it. Let's say we are asked to draw the free body diagram of this box resting on a horizontal surface, meaning that it is not moving. Okay, so before we draw our free body diagram, let's identify the forces that are acting on this box. Okay, from our previous lesson, we know that there is a force that is acting downward, a force that is acting downward on this box, and it is called the force of gravity or the weight. Okay, and also we know that there is a force that the surface is exerting on this box, and it is acting upwards, and we call it the normal force. Okay, so before we move on, please let it be known that this force, the normal force, is always perpendicular to the surface. So in every scenario that you get, the normal force will always be perpendicular to the surface. Okay, so now let's go ahead and draw our free body diagram. When we draw our free body diagram, we need to represent this box first. And how do we represent it? With a dot. We draw our dot there, and that is our box now. Okay, so from there we draw all the forces that are acting on the box. The first force, let's put our first force, which is the what? The force of gravity. This is our force acting downward. We label it, which is the force of gravity. Okay, since the box is not moving vertically, meaning it's not going up and down, it means that this force of gravity it is balanced with what? This normal force. Okay, meaning that this force of gravity that is acting downward, it is equal to the force or the normal force that is acting upwards, but in different directions. Okay, so when you draw your normal force on your free body diagram, make sure it is equal to the what? The force of gravity. Make sure that the length of this line that you draw here is equal to the length of that force of gravity, and it is straight. And then you label your normal force. Okay, so now what is the net force that is acting on this box? What is the net force? Okay, since the box it's not moving, the net force equals to 0. Okay, because the acceleration equals to 0, and we say that our net force equals to the mass multiplied by the acceleration. So any number that you multiply by 0 is going to give you 0. That's why the net force in this case equals to 0 Newton. Sorry. Okay, now let's say now we're asked to draw a free body diagram of a box being pulled on a frictionless surface. Okay, well, first we need to understand that whenever we see the word frictionless, we must know that there is no friction. Okay? Now, the question says draw a free body diagram of a box being pulled with a force F. Let's put our force with a force F on a frictionless surface. Okay? So, the first thing that we do, we represent our box on our free body diagram. Okay? And we know that there is a force that is going downward, and this force is called the force of gravity. Okay? Second thing, we know that there's a force that is equal to that force of gravity, and it's going upward. It's acting upward. And we call it the normal force. Okay? Looking at our diagram, we can see that there is another force now, and we look at the direction. Okay? We take this force, we put it on our what? Free body diagram. Okay? And we label it, which is force what? F, which is the force that is being applied. Okay. So, now we have seen how to draw a free body diagram of a force being pulled on a frictionless surface. But now, what is the net force? What is the net force of this box? Whenever we are looking at the net force, since the box is moving horizontally and not vertically, we will consider all the forces that are acting what? Horizontally. Meaning, we will come to our free body diagram, and which forces are acting on our horizontal plane? The applied force only. Okay? So when we calculate our net force, we're going to say our net force is equal to the applied force only. Okay? Remember, the net force means that all the forces that are acting on the object. And now, since we're looking at motion, we're looking at the forces that are acting horizontally on the object, because this box is moving what? Horizontally and not vertically. So that's why we said our net force equals to Fa, which is the what? The forces that are acting on the object or on the box horizontally only. Let's try another example. Let's say now we are asked to draw a free body diagram of a box being pulled on a rough surface. Whenever you see the word rough, you know that there is friction. Okay, there is friction. If they wrote frictionless, we know that there is no friction. But if they wrote a rough surface, we know that there is friction. So let's go ahead and draw a free body diagram. We will represent our box first. Okay, and we know that's the force that is acting downward, and this force is called the force of gravity. Okay, and we know that there is a force acting upward, and this force we call it the normal force, which is the force that the surface exerts on this box. Okay, now we can also see that there is a force that is being applied on this box. We check the direction. As we can see, it's going that direction, and then we put our force applied on our free body diagram. We label it force applied. Now this box is being pulled on a what? On a rough surface. And we said that whenever we see a rough surface, it means that there is what? A frictional force. A frictional force is a force that always opposes the motion. Okay? So since it opposes the motion, our box is going into this direction. It means our frictional force will go where? Into the opposite direction. Now we put our frictional force on our free body diagram, and this is our frictional force. Then we put frictional force, and that's how you draw your free body diagram. Okay, so now what is the net force? Okay, our net force equal to, remember this box is moving horizontally, okay, not vertically. It means when we are looking for our net force, we will look at what? The forces that are acting what? Horizontally. Which forces are acting horizontally? Looking at our free body diagram, it's going to be the force, it's going to be the force applied plus the frictional force. Okay, but now when you do your calculations, remember your force applied is going to a certain direction and your frictional force is going to another direction. So whenever you do calculation, make sure that you put a negative sign for your frictional force to show that it is what? Opposing the motion or the direction of the motion. Okay, and that's it for our today's lesson. And next we will look at forces that are applied at an angle. Thank you so much for watching. Drop any comments if you have any question or any concerns. Thank you so much. See you again.